Dear students, let us understand n-queen's problem through backtracking. Before actually going to the solution of n-queens, let us understand what is backtracking. And also before actually going to the definition of backtracking, let me take a small example to make you understand backtracking. Let us assume Ramu has to go from source to destination in his car and Ramu do not know the path, he does not know the route. Let us take this example. So Ramu is at the source, he will pick one path randomly. So this is the path that he has taken. So he moves in that particular path for some time. After traveling for some time in his car, at the dead end, he will find a forest. So, can Ramu travel in his car? No, because wild animals are doing meeting at the dead end. So, what he has to do? He has to turn back. So, instead of using the word turn back, we use the word backtrack. So, in this path, Ramu has reached a step. Further, there is no possibility of solution, therefore, he backtracks. So, he backtracks, comes back to the same point. Now, Ramu has to choose another path. Yes, Ramu chooses this path, travels for some time, he gets another point there. And from that point, he has to choose another path. Yes, he takes this path, travels for some time. After traveling for some time, he finds a sea. There is an ocean. He finds a sea, ocean. So, can he travel on this ocean in his car? No, unfortunate Ramu. So, he has to backtrack again. Again, he will come to the same point. From here, he will take another path. Yes, Ramu takes another path, travels for some time, he gets mountains. Oh, this time he has got mountains. So at the dead end, he has got mountains. So can he proceed? No, he cannot proceed. He cannot travel over the mountains in his car. Therefore, he backtracks, comes back to the same point. Now Ramu has to take another path. Yes, he chooses this path. He goes to this particular point. From this point, again, he has to choose one more path. He chooses this path, travels for some time. He finds a desert. This is a desert. So, can he travel over the desert in his car? No, he has to backtrack. So, Ramu backtracks to the same point. So, now Ramu has to choose one more path. He selects this path. So travels for some time, he reaches the destination. Very good. At last, Ramu reached the destination. See, in this example, you can understand at a particular step, if you are sure that solution is not possible, backtrack to the previous step and take an alternative path. That's the basic concept of backtracking. So now we shall go to the formal definition of backtracking. Backtracking is a technique in which, if it is not possible to find a solution from a particular step, we backtrack to the previous step and continue solving using an alternative path. This is what Ramu did in the previous example. And also, what are the general steps of backtracking? Start finding the solution. At each step, check whether solution is further possible. If solution is further possible, continue in the same path. Otherwise, backtrack to the previous step and take an alternative path and continue. So the general steps of backtracking are as follows. Start finding a solution. At each step, check if there is a possibility of solution from that step. Check if there is a possibility of. If there is a possibility, continue finding solution in the same path. Otherwise, backtrack to the previous step and continue solving using an alternative path. That's all backtracking. This is the concept of backtracking. Next, we shall go to n-queen's problem. See, in n-queen's problem, we have got one n cross n chessboard and also we have got n queens. What we have to do is we have to place these n queens on that n cross n chessboard in such a manner that no two queens are placed in the same row, same column or same diagonal. So in a n queens problem, there are n queens and a n cross n chessboard. Yes. The problem is to place n queens on this n cross n chessboard with the following constraints. What are the constraints? No two queens should be placed on the same row. No two queens should be placed on the same column. No two queens should be placed on the same diagonal. That's all the n queens problem. So how to solve this problem using backtracking? I'll take a small example. 4 cross 4 chessboard. So these are the column numbers 1, 2, 3, 4. row numbers 1, 2, 3, 4. So this is a 4 cross 4 chessboard. We will try to place 4 queens on this 4 cross 4 chessboard. First queen I will place in the first row. Yes, first queen is placed. Can we place the first queen here? Yes, that is the only queen, no problem at all. So fine. Now second queen should be placed in the second row. We shall try to place the second queen. Yes, we place here. Is this okay? No, it is not okay because they fall on the same column. Therefore, what to do? Increment the column. Yes, we place the queen. Next, is this okay? No, this is also not okay because they fall on the same diagonal. Therefore, what to do? Increment the column. Yes, move it here. Is this okay? Yes, this is okay because these two queens are not on the same row, same column or same diagonal. That's okay, no problem at all. So second queen we have placed. Now we will try to place the third queen. So third queen should be placed in the third row. Yes. Is this okay? No, this is not okay because they fall on the same column. What to do? Increment the column. Yes. Is this okay? No, this is also not okay because they fall on the same diagonal. So what to do? Increment the column. Yes. Is this okay? No, they fall on the same column. Therefore, what to do? Increment. Is this okay? No, they fall on the same diagonal. What to do? Increment the column. Now, when you increment the column, the queen will go outside the chessboard. Is it okay? No, this is not at all okay. Queen cannot go outside the chessboard. Now, in the third row, we could not find any positions for the third, any column for the third queen to be placed. Therefore, the queen went out of the chessboard. So, when this happens, you have to backtrack to the second row. So we backtrack to the second row and we move this queen. Find a new position for this queen. Yes. This position, is it okay? Yes, it's okay, no problem because these two queens do not fall on the same row, column or diagonal. That's okay, no problem. So second queen, we have formed a new position. Now third row queen, we start. Yes. Here, is this okay? No, because they fall on the same column. Increment the column. Is this okay? Yes, this seems to be okay. So when you place this queen, no two queens are there in the same row, same column or same diagonal. This is okay, no problem. So third queen. All of us almost are in a feeling that we have come to the end of the solution. If you place one more queen, the solution is got. Let us see what happens. So we have to place the fourth queen in the fourth row. Yes, we start here. Is this okay? No, they fall on the same column. Increment the column. Is this okay? No, they fall on the same column. Not okay. What to do? Increment the column. Is this okay? No, they fall on the same diagonal. What to do? Increment. Is this okay? No, not okay. They fall on the same column. Therefore, what to do? Increment. Is this okay? No, not at all. Queen cannot go outside the chessboard. So when queen goes outside the chessboard, it means fourth row. We could not find any place for the queen. Therefore, what we have to do? Backtrack. Backtrack to the third column and try to find a new position for the queen. So increment the column. Is this okay? No, this is not okay because it falls on the same diagonal. What to do? Increment the column. Is this okay? No, they fall on the same column. What to do? Increment. Is this okay? No, third queen also has gone out of the chessboard. Queen cannot go out of the chessboard. So when queen goes outside the chessboard, what you have to do? Backtrack to the previous row. Yes, we backtrack. So we increment the column of the second row queen. So second row queen also has gone outside the chessboard. No, we cannot move the queen outside the chessboard. Therefore, what we have to do? Backtrack to the first row. Yes. Increment the column. Yes, we have found a new position for the first row queen. Is this okay? Yes, this is okay because there is only one queen. Now we try to place the second queen. So can we place the second queen here? No, because diagonal. So what to do? Increment the. Can we place here? No, column wise there is a problem. So what to do? Increment column. Can we place here? No, they will be on the same diagonal. Therefore, what to do? Increment the column. Yes. Is this okay? Yes. This is okay because queens are not on the same row, same column and same diagonal. This is okay, no problem. Second queen we have found a position. Now third queen we shall try to place in the third row. Yes. Is this okay? Yes, very good. First time, first column only it is okay. No queens are on the same rows, same columns and same diagonal. Yes, it is okay, no problem. Now we shall try to place the fourth queen. Is this okay? No, column wise there is problem. Increment the column. Is this okay? No, this is not okay. They fall on the same diagonal. Therefore, what to do? Increment the column. Is this okay? Yes, this is okay. This is okay because no queens will fall on the same row, same column or same diagonal. We have got the solution. So I think with this demo we understood how actually we should solve the n queens problem. We shall go to some of the concepts and then we shall design the algorithm. First, how to make sure that two queens should not be in the same row. See, for this we consider a one-dimensional array X which can store values from 1 to n to store the positions of the n queens. Why 1 to n? Because n queens are there. X can store the column numbers of all the n queens. X of 1 will store the column number of the first queen of the first row. X of 2 will store the column number of the second queen of the second row. Likewise it goes down. Now in this array, array index represents the row number and value represents the column number. We will take some examples. X of 1 is equal to 3 means first queen is placed in the first row and third column. Another example, X of 2 is equal to 4 means second queen is placed in the second row and fourth column. X of 3 is equal to 1 means third queen is placed in the third row and first column. In general, if X of k is equal to A, it means kth queen is placed in the kth row and 8th column. Now, X of 1 can store only one value. It automatically makes sure that in one row there can be only one queen. This also ensures that only one queen is placed in a row. No need of additional logic to make sure that two queens are in the same row. Automatically it happens. This also ensures only one queen is placed in a row. Fine. No problem. Next, no two queens should be in the same column. How to ensure that no two queens are in the same column? See, assume k minus 1 queens are already placed and we are trying to place the kth queen. So kth queen should be placed in the kth row. K minus 1 queens are already placed. Where is the first queen placed? First queen is placed in the x of 1th column. That is, x of 1 will contain the column number of the first queen, x of 2 will contain the column number of the second queen, x of k minus 1 will contain the column number of the k minus 1th queen. This means the values in x of 1 to x of k minus 1 are already stored. These are the column numbers of the queen. Suppose we want to place the kth queen in the 8th column, that is x of k is equal to a. So how do we know that kth queen can be placed in the 8th column? If we have to place the kth queen in the 8th column, none of the queens from 1 to k minus 1 should have been placed in the 8th column. No queen should be there in the 8th column. Now, we have to check if any of these k minus 1 queens are already placed in the column A. For this, we have to compare A with all the values from x1 to xk minus 1. I think we can use a simple loop here. Say A is equal to 1 to k minus 1. If x of I, any of the column numbers of the previous queens, if it is equal to A, already there is a queen placed in this column. Otherwise, yes, kth queen can be placed in the column A. None of the queens are in column A, yes, kth queen can be placed. That's all. This is a simple logic to make sure that no two queens are in the same column. Next, no two queens should be in the same diagonal. See, this is a not difficult logic, but carefully we should understand this logic. To make you understand this logic, I'll consider one 4 cross 4 chessboard. So, column numbers, row numbers. I'll take some queens randomly. And example 1. I'll take one queen at 1 comma 2, first row, second column, and the second queen at third row, fourth column. So first queen is at 1 comma 2 and second queen is at 3 comma 4. Now carefully understand, we'll find the difference between the rows and difference between the columns for these two queens. Meaning, first queen is in the first row and second queen is in the third row. What is the difference between the rows? 2. Difference between 1 and 3 is 2. Now we shall find the difference between the columns. First queen is in the second column, second queen is in the fourth column. So difference between 2 and 4 is 2. You can see here, absolute of 1 minus 3 means this is the difference between the rows. Absolute of 2 minus 4 means this is the difference between the columns. Difference between the rows is also 2, difference between the columns is also 2. Whenever the difference between the rows and the columns is same, the two queens are on the same diagonal. Yes, the two queens are on the same diagonal. Carefully understand. If the difference between the rows and the difference between the columns, if it is same, it means the two queens are on the same diagonal. Okay, let me also illustrate this with another example. So I will consider one queen here, 1, 3, first row, third column. Another queen, third row, first column. Now, we shall find the difference with respect to the rows. First queen is in the first row, second queen is in the third row. Difference between the rows is 2. Let us take the columns. First queen is in third column, second queen is in first column. 3 and 1. Difference between 3 and 1 is 2. Meaning, here also the difference between the rows and columns are equal. The difference between the rows is 2, difference between the columns is also 2. Since they are equal, they fall in the same diagonal. The two queens are on the same diagonal. Yes. Let me illustrate with one more example. Example number 3. Now I will consider the queen at 1, 1. First queen and second queen at 4, 3. Let us find the difference between the rows. First queen is at the first row. Second queen is at the fourth row. What is the difference between 1 and 4? 3. 1 and 4 is 3. Let us find out the difference between the columns. First queen is in the first column, second queen is in the third column. Difference between 3 and 1 is 2. So what is the difference between the rows? 3. Difference between the columns? 2. Are they equal? No, they are not equal. When they are not equal, it means the two queens are not on the same diagonal. Difference between the rows is not equal to the difference between the columns. It means the two queens are not on the same diagonal. So in general, this is an important logic. When queen 1 is at R1 C1 and queen 2 is at R2 C2, difference between the rows between R1 and R2 difference between the column, difference between C and C2, if they are equal, then the two queens are on the same diagonal. Otherwise, the two queens are not on the same diagonal. Very simple logic. I think you need to remember this logic because we will use this logic in the algorithm. Now, let us design an algorithm to check whether the kth queen can be placed at the kth row and ith column. So, we have to just check whether this queen can be placed in the kth row and ith column. That's all. This algorithm returns 1 if queen can be placed, otherwise it returns 0. Simple. And also carefully understand, when we are checking for the kth queen, already k minus 1 queens are placed in x1 to xk minus 1. x1 will contain the column number of the first queen, x2 will contain the column number of the second queen, like that it goes. So already these values are stored. We will name the algorithm as place kth row ith column, whether a queen can be placed. That's what is the algorithm checking. So for j is equal to 1 to k minus 1, we have to check with all the previous k minus 1. X of j is equal to I. This is column check. We are checking whether there is a column clash. Absolute of j minus k, row difference. Absolute of x of j minus I, column difference. Diagonal check. If there is any clash with respect to the diagonal. Now, if any of the queens from 1 to k minus 1, either there is a diagonal clash or a column clash, then return 0. If it does not clash with any of the queens from 1 to k minus 1, then it comes out of the for loop, then you return 1. Meaning there is no clash either column wise or no clash either diagonal wise. Queen can be safely placed at the kth row and ith column. So it is returning 1. So it's a simple algorithm. This algorithm we will use for the n queens final algorithm. So now we come to the n queens algorithm. Name of the algorithm is n queens. N. So k is equal to 1, meaning we are starting from the first row. X of k is the column, we initialize to 0. K is equal to 1 means we start from the first row. Okay. Well, k is greater than 0. When k is greater than 0, it means there is a possibility of solution. When k becomes equal to 0, meaning solution is impossible, we cannot get the solution. So k is greater than 0. So what you have to do is x of k is incremented, meaning x of k was 0. When you increment, it becomes 1. So x of k is becoming 1. Start from the first column. While x of k is less than or equal to n, x of k is less than or equal to n means what? It means we are still within the chessboard. It has not gone outside the chessboard. And we cannot place the kth queen in the x of kth column. See, column is less than or equal to n still. X of k we cannot place. What we have to do? Go to the next column. So x of k should be incremented. Carefully understand. If kth queen cannot be placed in the kth row and x of kth column, go to the next column in the kth row. That's all. Increment x of k is equal to x of k plus 1. Go to the next column. Now, this logic neatly understand. When you come out of the while loop, if x of k is less than or equal to n, it means we have found a position for that particular queen. Column found to place the kth queen. Yes, we have found the column. If k is equal to n, if k is equal to n means we are trying to place the nth queen, last queen, meaning we have got the solution, therefore print the solution. Okay, when k is equal to n, it means all the n queens are placed and the solution is complete. Yes, very good, print the solution. Otherwise, if k is not equal to n, in the kth row you have placed a queen, therefore you have to go to the next row, therefore increment k. Yes, k plus plus. Not only incrementing k, you have to make the column start from the first position. For that, x of k is equal to 0, it will become 1. Immediate statement of the while loop will make it 1. So this is going to the next row. Go to the next row and start from the first column in this next row. Very good. Otherwise, if x of k is less than or equal to n, it means you have got a position. Otherwise, you have not got a position in the kth column. Therefore, you have to backtrack to the k minus 1 column. Therefore, else k minus 1. If kth queen could not be placed in any column in the kth row, and hence we have to backtrack to the previous row k minus 1. Meaning kth row could not be placed in any of the column in the kth row, so we have to backtrack k minus 1. That's all the algorithm. That's all the algorithm. See, n queens problem is a simple solution using backtracking. I think any value of n, you should get the solution for this n queens problem. I hope all of you should be able to write the code also quite easily in any language, whatever is you are comfortable. You should be able to write the code also quite easily, no problem.